Today, we will be talking about the BOT-2 test, which is widely used for motor proficiency examination. This assessment is for school-age children ranging from 4 to 22 because you can only be 22 to be in public schools. This assessment is quite lengthy, so you want to make sure you allot enough time, and it will probably take your entire assessment process. So you have roughly, it takes between 40 to 60 minutes, but you can do some sections individually. The materials needed are a table to take part of the assessment on, 2 chairs with backs for good body alignment, one for you and one for the client. You're going to use a red sharpened pencil, the BOT booklet and manual, and an administration easel. You need a recording form, 15 blocks, 50 cards, pegs with 30 pegs to go along with it, pegboard with 30 pegs to go with it, 20 pennies, a penny pad, a shuttle block, target, balance beam, a box, knee pad, scissors, string, tennis balls, stopwatch, measuring tape, tape measure, and tape. So this assessment is broken down into 4 areas. You'll be looking at fine motor control, manual coordination, body coordination, and strength and ability. And those 4 areas will be broken down into 8 subtests. So to start, you have manual control, fine manual control, which is broken down to fine motor precision, which there's 7 tests or items you will evaluate, and then fine motor integration, which there's 8 items or tests you'll evaluate. And here is an example of that assessment.
For our pediatric assessment, we have the BOT-2, and to demonstrate it, we're going to be doing the fine motor precision and integration subtest. So for the first subtest will be for the precision. So first what you would do is instruct your patient that they're going to fill in the small circle and the small star with a red colored pencil, and then they'll be graded on how well they fill in the circle and the star on a scale of 0 to 3. So we'd instruct the patient, can you fill in the red circle as best as you can? Now can you fill in the star as best as you can? Good. Now we would take her coloring and compare it to the chart. So she has it completely filled in on both, so she'd get a score of 3 for this. So for scoring wise, she'd get a raw score of 3 for both, and then we'd circle 3 over here for point wise, and then for point score we'd add 3. And then we'd go through all of the other assessments for the fine motor precision of drawing lines through paths, connecting dots, folding paper, and cutting out a circle. We'd do a raw score, circle it, and write it in the point score, and overall we'd add it up and get a total point score down here for the precision test. Now for the fine motor integration test, this activity is going to be the patient copying a circle and a square in the boxes below, and then it'll be scored the same way. Okay, now can you copy this circle in this box here? Good. Now can you copy the square in this box here? Good. So for grading purposes on this and for scoring, you would compare it. So for the circle, it's scored on as 1 to 4 points. So it goes off basic shape, closure, edges, and overall size. So for each one, you would see if she gets a 1 for each of them. So going to the score sheet, you would see that she copied it pretty closely. So she'd get a 1 for that, a 1 for that, and 1 for that. And it doesn't do any orientation or overlapping, but they do overall size. So she gets a 4 here and a 4-point score. And then for the square, it's on a scale of 0 or 1 to 5. So you'd look at that and it's pretty much closely the same, and that goes off basic shape, closure, edges, orientation, and overall size. So we go to the score sheet, and she has basic shape, basic closure, the closure, edges, orientation. There's no overlapping, and she has overall size. So she'd get a score of 5, and she'd get 5 over here. And then you would repeat it for copying overlapping circles, copying a wavy line, a triangle, a diamond, a star, and then overlapping pencils. You'd score it the same way of what it's asking of a 0 or a 1. You'd add in the raw score, and then you'd add up the point score total, and you'd get your total overall score at the bottom there.
So as you can see, the manual is very laid out and detailed of how to score, and it's very hard to skew the information you need from the scoring. But also, as you see, is all 7 of these tests or items will be a raw score that you add up for your subtest score. So scoring is laid out for you visually. So if you are a visual instructor, it helps you that way. Or if you are an oral instructor, it helps you with the words. But each activity, so all 7 of these will get a score, which is the raw score that you will then add for an overall score. And same throughout this. So your manual dexterity, you will add up 5 scores to get your total. And upper limb coordination, which is all part of manual coordination, all those will be added up. And then you do have body coordination, bilateral coordination, balance, strength and agility, which is running, speed with agility, and strength. So total, you will have 53 raw scores or test items that you then will add together for these subtest scores. But here's a visual of your body coordination, so balance coordination, bilateral coordination of balance.
Now we're going to do the same thing you just did, but instead of standing in one spot, you're going to take 6 steps. Make sure you're not heel to toe and that your legs are spread apart, about a foot in between each foot. Ready? Begin. Nice job. On to the next one. This one is you're going to stand on one leg. It's going to be your preferred leg on the line, whatever leg you would like, and you're going to stand there. Make sure that the leg that you're using is at a 45-degree angle up, and you're going to stand there for 10 seconds. Ready? Begin. So, nice job. Now this is going to be the same thing that you did the first one with the standing, but instead of with your eyes open, you're going to have your eyes closed. You're going to stand for 10 seconds. So you're going to take your preferred foot forward, stand there, eyes closed. Ready? Begin. Nice job. Next one we have, this is what you're going to do the walking, but instead of having your feet spread apart, it's going to be heel to toe. You're going to do a total of 6 steps heel to toe, as straight as you can on the line. Ready? Begin.
And if you can tell here in the manual, there's visuals of what it should look like that you're asking the patient to do.
Perfect. Now back to standing on one leg, preferred leg, but you're going to stand on one leg. Make sure the other leg's at 45 degrees up, and you're going to have your eyes closed. 6 seconds, or 10 seconds. Ready? Begin. Leg up. Perfect. Nice job.
Given this data is standardized as well, you want to make sure that you're saying it as closely or as accurately to the written word. So as you can tell in that moment, he corrected his standing because his leg was too low, which could affect his balance, make it easier. And he also corrected himself in the fact that he didn't let him do 6 seconds like he originally stated. He made sure to clarify that it's for 10 seconds.
Let's actually try that one more time. Eyes closed. Make sure that leg is at 45-degree angle all the way up. Ready? Begin.
And he's taking the time to go back to make sure everything is done correctly so it's not deviating from the standardized test.
Perfect. Nice job. Now we're going to get the balance beam. We're going to be standing on one leg on the balance beam. So it's the same thing you just did. Eyes open, but you're going to be standing on the balance beam. Again, make sure that leg that you're going to be lifting up is at that 45-degree angle. You got 10 seconds on the balance beam. Ready, begin. Nice job. Now we're going to do heel to toe on balance beam. You're going to be standing just like that, balancing for a total of 10 seconds. Make sure that heel is touching the toe. Perfect. Begin. Stop. Nice job. This will be our last one in this category. It's going to be standing on the balance beam, one-legged, preferred leg, other leg 90 degrees up, but you're going to have your eyes closed. You're going to have 10 seconds. Ready, begin. All right, let's try this one more time. 2 tries. Are you ready?
Yep, I'm ready.
Ready, begin. Stop. Nice job.
These are some minimum and raw score numbers looking at the subtest. So you have eyes open 10 seconds, eyes closed 10 seconds will be 0 out of 4. Walking eyes open, as they said, 6 steps, you're scoring 0 out of 4. Standing with one leg 10 seconds, 0 out of 4. The only one that deviates is scoring. So when you tally up this whole raw score section, the raw scores can do a total score. Your total will be 0 out of 24. So that was one section if you go back out of our bilateral coordination. And then when you do the second part, so the balance, it'll be 0 out of 36 because then you'll add in all the others for a raw score. Right here, we have some subtest areas looking at boys and girls means and standard deviations. If you notice a theme throughout all of these, girls have a higher mean along with a smaller standard deviation typically, which I find interesting given scientifically guys mature slower than girls. So even though boys are thought to be more supreme athletically, girls still have a different mean than them in a positive way. And here's a link that I provided that just shows you a complete report, a form report, so you can look through and see what that would look like. So you have the date, the test day, the name, the student exam number, basic information about your patient you'd be seeing. You'd put their total points scored and the scale that it was on. And then some of these will have a standard score like your fine manual control does. You would look at their percentile rank because this is standardized. So you can see that this person in fine manual control performed above average based off their percentile rank, just like you kind of do when you go to the doctors for height. So this is just a sample standard score difference here. Scale score difference based off how they did in these activities. This is a normal curve to see how they fall within the curve. So you can see more on a visual standpoint where they're below average and where they fell above average. And this is just a different way you can display the data. And that is all.